I've recently released one of my earlier projects that I've been working on, which was the solar boiler controller. And today I'm gonna publish another project which I was working on for a while now, which is the pellet burn controller. This one is controlled by an ESP32. It has a real-time clock, encoder, some relays, and a display to show the current state of the project. This video is sponsored by Altium 365 and its great electronic part search engine Octopart. Octopart is a real-time part selection assistant and search engine that is used as primary source for component data in Altium Designer and Altium 365. Octopart gives you the most up-to-date part data like specs, datasheets, and CAD models right in the design environment, so you can focus on your designs. With the built-in stock level tracking, you can always be one step ahead of the current supply risks and get automated notifications for low stock levels. Keep your design momentum going by having the right component info handy in the design environment, and trust Octopart to recommend the best components to fit your criteria so you can focus on problem solving and creative thinking. Visit the link in the video description to get your Altium Designer free trial along with a free subscription to Altium 365, and visit octopart.com to find the right components for your next project. We currently have over here in the corner, we have a thermistor that measures the temperature, which is displayed here. So this entire project is a work in progress, so it's not a finished part by any means. I'm still missing a few components that I need to add to this one, but I just wanted to share this project and open source it. So if anyone is willing to help me out, then they can join the development of the software, and then we can provide this for free if there are people interested in using the controller. So just to give you a quick rundown on how this works. The relays here, you can see that they are labeled. I have one for the heater, I have one for the pump, and another one for the feed that brings the pellets in. So when we start the process, the idea is that the ESP32 will control that process and turn on the parts as required to keep the constant temperature that we want to set here. On the display here, you can see that we have the date and time on the top. Then we have the target temperature, which we want to achieve. We have the current temperature as measured by the thermistor. And then below that, we have the current state that the whole controller is in. And that can go from standby to ignition, then to stabilization of the flame, then to heating, and the final stage is the shutdown. There are a lot of things that you can adjust with this controller, and all of those settings are accessed by pressing on the button that's present here on the rotary encoder, and you can see a full video on how you can achieve that. I have a separate video for that. You can also find separate videos on how to work with the rotary encoder, how to work with the real-time clock, and also how to control relays with the microcontroller. So I won't be covering that, and I'll just focus on the device itself. So let's start by me walking you through the settings on the controller. By clicking, you're entering the settings menu, and by clicking, and once again, you're cycling through all of the settings that you can apply to the controller. So, and if you release it, then it will go back to the standard display mode. So let's go one by one. The first one is the target temperature that we can just, then by spinning the encoder, we can adjust the target temperature, and that would be the temperature that we want to achieve on the water as measured from the thermistor. Next, we have the ignition time, or how long the whole ignition sequence should last. And there are a few more settings like that for like the stabilization time and different times. So the stabilization is 6 minutes, then the cleaning interval to run the fan, that's still not present on the setup, but it will be, to run the fan every 30 minutes. Then we have for how long that cleaning should last, then what's the start dose of pellets that needs to be added, and then three settings for the different dosages and fan speeds that we need to have. Then we have the smoke temperature, which will be another thermistor right here that is currently not connected, and we'll measure the temperatures of the smoke coming off from the exhaust. We have the cutoff temperature on where that heating should stop in case something goes bad, and what's the maximum temperature of the smoke, when should the pump turn on, and we have the settings for the current hour, minutes, and date, and we have the temperature adjustment at the end, from which we can adjust the display temperature that's on the thermistor if by using a different thermistor there's some difference in the values that they give off. The code running on the controller is written in Arduino IDE, so I'm using Arduino to control the ESP32. And other than the settings and the real-time clock, there are a few interesting functions that I want to go over when demoing this. And the first one is the function that controls the output of the pump. Anytime that we have enough temperature difference as set on the controller, we need to have the pump on no matter what's the state of the controller. So if we have heat available inside the boiler, then we need to distribute that heat throughout the system. So if I'll use a lighter to heat up the thermistor, and we'll see that as soon as it goes over the set temperature, the relay for the pump is being turned on, and it will stay on until the temperature goes 2 degrees below what's set as a temperature. So you see now it turned off when we went down, and if it heats again, then the pump will turn on again no matter what's the state of the system. So this will control the pump until there is heat available in the system. Next up is the control for the heater and for the feed. And for that, I'll need to turn on the controller. To turn it on, you just need to press this button on the rotary encoder for 5 seconds. And that gives a solid indication that we want to ignite the burner. And we now turn on the heater relay. So you can see the in4, and you see now it starts to feed in pellets. So during the ignition time, the feeder will work for the set period of time, and then we'll have the heater. Ideally, we will also have a check for the temperature of the exhaust gases coming out of the heater, and that would control the period as well. Now we went into the stabilization mode, and during that stabilization mode, the feed relay will be turning on and off on a period as set on the controls. We had that set for, I think it was 30%. So in any 10 seconds, the feed relay will be on for 30 seconds if we have 30% duty cycle. And that lasts for some time until then it transfers into the heating mode. Actually, in the stabilization, I think it was 10%, and now in the heating is 30%. So the relay stays on for 3 seconds every 10 seconds, and that means that we have a constant supply of pellets that are coming into the burner. What I haven't implemented yet in this stage is the control for the different power rating. As you saw in the settings, we had 3 different power ratings that the heater can run on, and that power rating will be identified based on the difference in the current temperature. So the lower the difference from the current temperature to the set temperature, to the target temperature, the higher the power output of the whole system will be. And this ideally should go on and run for as long as needed. We also need to build in a protection that will turn off the entire system if it goes above the set temperature. And then if you want to turn the whole system off, then you just again press and hold for 5 seconds, same as with turning on, and that puts the whole controller into the shutdown mode. And during the shutdown mode, we'll need to be monitoring the output temperature and make sure that everything is nice and cool before we can revert the whole thing to be into the standby mode. And from there on, we can start the whole sequence again when needed. Another feature that I want to add to the controller, which is currently not implemented, is the ability to control it to with an external thermostat, like the one that you're gonna have in your living room, and then that will connect to the ESP either by wire or wirelessly. We'll see how that goes, and that can give on the signal to turn on or turn off the controller and the pellet heater, so you can have like a constant temperature within your living space. This controller is quite far from being done, but it's getting there, and I'm working on it as far as I can. The idea now is that I will open source this, so you'll have the schematic, the code that runs on the controller, so you can build it yourself and maybe even add features to it. That's the beauty of open source. We can all work on the controller together and make it better for everyone. And we can provide it for people that want to build their own systems, because I've seen online that many people are trying to make burners and also to make their own systems, but something like this is lacking. So there is not a good solution that you can just build yourself and customize it to your own hardware that you have. So all of the links for the code, the schematic, and everything required will be down in the video description. Make sure to check it out. Make sure to subscribe to see any further updates on the controller as I make them. I'm not sure when, but the idea is that I'll use some of my free time to build it, and maybe even build a custom PCB or something like that for the whole thing. So be sure to subscribe. Make sure to like and share this video if you think it's valuable to any people that you know, and I'll see you all in the next one. Cheers.